Okay, counting principles is our first topic. A soccer team has 3 colored jerseys, red, white, and black, and 3 colored shorts, red, white, and black. Draw a tree diagram to represent all the different outfits they could have. Okay, so let's start with, what do you want to do, shorts? First of all, they could wear red, they could wear white, or they could wear black shorts. Okay, if they were wearing red shorts, they could wear red shorts with a red top. They could wear red shorts with a white top, red shorts with a black top. If they were wearing white shorts, they could go white red, white white, or white black. So how many different outfits were possible in this whole scenario? Nine. Yep. So if you were to list them, they'd be like this, like red, 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 white, right? Red, blue, black, da da da. If you were to make a list, there would be 9 different things. Okay. So the concept of this is to do those options times those options. So what if you had a situation like this where you had 3 appies to pick from at a restaurant? Appies, appetizers. Oh. You had 5 main courses to pick from and 2 desserts. So how many different ways could you make your meal if you're going to have an appetizer and a main and a dessert? How many different ways could you make yourself a meal? 30. There's 30. Let's say you could have wings with a lasagna meal with a cookie. You could have wings with a soup meal with a cake, right? Like you could have 30 different ways to make yourself a meal. Okay, so that's that concept. So it's called a fundamental counting principle. If there's A ways to do one thing and B ways to do the other, then you just times them. Okay? Okay, a luggage lock opens with the correct 3-digit code. So we have to put in a 3-digit code. Each wheel contains the digits 0 through 9. Okay, so on this code, I could pick the digits 0 through 9. How many options do I have? 10. From 0 to 9, that's 10. How many options do I have in this spot? Also 10, because I could pick any digit 0 to 9. And in this digit spot, I could pick 10 different options. So I times, and that makes 1,000. This makes me think of, do you guys know your PIN number for your bank is a 4-digit code? Mm-hmm. So how many possible PIN numbers can your bank code be? Think of it. 10,000 options, because 10 times 10 times 10 times 10. When me and my husband, we were dating, I had to I'm like, here, I need you to grab me something with my debit card, and I gave him my PIN number. He looked at me and he's like, we have the same PIN number. Yeah. So what are the odds of that? 1 in 10,000 chance that that was to happen. And that's why I married him. Because the math, the probability. Okay. Suppose now that each digit could only be used one time. So you can't repeat it. So let's pretend I used an 8 here. Now the 8 is out of the options. Okay. So how many options would I have on my first wheel spin? 10. How many options would I have now? Now I only have 9 numbers to pick from because I can't repeat the one I used. How many options do I have here? 8. So now that's 720 different digits, codes. Okay, cards. Do we know our cards?
Was there? I think so.
Okay, how many suits do you have? Suits. Suit is like a heart, a diamond. What do you have? You know your cards. What do you have? What's this top one called? Oh, what? What is this? Yeah, no, that's a club at the top. That's a club. It's a 4-leaf clover. Then this is a spade, hearts, and diamonds. Okay, so you have 4 suits. How many in each suit?
Suit 13.
13. Because you have 1, 2, 3, 4, 5, 6, 7, 8, 10, and then Jack, Queen, King. That makes 13. How many cards are all together then? 52.
Do you guys want to know this? You're playing with a deck of cards.
Cards, guys. Cards.
Big book.
Okay. If I say face card, what is a face card? It has any face on it, which is a jack,
How do you know if you never
jack,
picked up
a
deck of cards?
queen, and a king. How many face cards are there in the whole deck?
12.
12. 3 times 4.
Oh gosh. I reached down.
Okay, so some of you I might have to print this sample space for.
Yeah, you probably.
And that's fine, I will.
Bring a deck of cards.
4, 13, 52. Some numbers to know about cards. Okay, you guys need to play more cards. How many possibilities do you have of getting either a black face card or an ace? Black
Can the ace be any color?
ace is any color.
Oh, sorry.
How many black face cards are there?
39.
Black face cards.
So isn't it just like 10 out of 52 chance?
There's 13. 26.
How many black face cards?
6.
6. 1, 2, 3, 4, 5, 6. There's 6 black face cards. Or I could get an ace. 4. So how many?
10.
10. There's 10 possibilities.
You don't understand that.
There's 6 possible ways I could get
There's
a
6 black face cards.
black
There's
face
4
card.
aces, so it's 10.
4 ace cards.
What's an ace?
So how?
A 1.
An ace is a 1.
I feel like I need to print that diagram.
An ace is an A.
Yeah.
Okay, I can print this later
Yeah,
when I'm done teaching. Okay. So that's 10. How many possibilities do you have of getting either a red card. How many red cards are there? 26. See, you're catching on. 26 red cards. Or a 10. How many 10s do you have? You have 4 10s. But, what did we do here?
Can't count them twice.
You can't count them twice. Look at this. Red cards, we would have counted those 2 10s,
Challenge the example.
right? And then you counted these 2 10s again. You counted these 10s twice. So,
Oh.
you have to get rid of the ones that you counted twice. Okay? Or you can think about if you took out all of the red cards from the deck, that's 26, right? And then all the 10s, there's only 2 more 10s to take out, right? So now that's 28 cards. Do you see the overlap though? Because the 10 of hearts and the 10 of diamonds belonged to each category and you counted them, which you can't do twice. Okay. Factorials. Permutations, factorials, lots of new words. Okay. How many arrangements can you do when you line up 6 children to get a drink? So they all are lining up for the water fountain. So there's my 6 spots in the line. How many options do I have to put somebody right away? 6. How many options do I have to put somebody into the next position? 5. Then what? 4, 3, 2, 1. Okay. You can do that in your calculator, but I'm going to show you a fast way. This is what we call a factorial. A factorial is when you times and go all the way down like that till you get to 1.
But not 0.
No, because 0 makes 0. Once you include 0, it makes 0. So.
Did Sam have the red liner in here or no?
No.
Okay, then I'll remember when you have it.
Okay. Right, if you times by 0, then the whole thing would just be wiped out. So you don't want that. Okay. I know that we have our like special calculators, but when you are using this unit, it's actually better to not use that calculator. But I will show you how to do it. It's just that then you have to go into like a menu and everything. Okay. So on my regular calculator, do you see how mine on this one is just an exclamation point above the 4? Okay. So 720. Okay. You guys are on your special calculator. So you have to go 6. Okay, now the button math. You see the math button? And then you go over to probability. And then you go to your exclamation point. See how that's like a lot longer than your just a regular calculator? So it's like possible, but it's going to be harder. Okay. And if you really got to know, does it work? Yeah. Okay. So factorial, obviously we go in a descending order of numbers. So if I did n factorial, the first number would be n. What's the second number? N subtract 1, n subtract 2, n subtract 3, da 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 da, so on, right? Right? Because if my number is 6, this is 6 minus 1, and this is 6 minus 2, 6 minus 3, in that order. Okay. Evaluate. So can you practice that? 10 factorial. See if you can find your button.
Wait, what?
Can you practice that in your calculator? 10 factorial button. I just want you to see about your calculator typing.
Yo, mine says it's not clear.
That's a big number.
Yours said error.
But I tried the second one.
Oh, you're on the second one?
Yeah.
Don't do it yet.
I'm trying to do
Because I'm going to show you something different with it.
it. Yeah?
Yeah. Okay, how's are we good?
Yeah.
10 factorial, okay. So we know where our button is. Okay, next one. So I'm going to start expanding this out. So 12 times, what's the next one? 11 times 10 times, am I going to keep going here forever? I'm going to actually stop. Because what happens, everything from here on out, 9, 8, 7, 6, 5, 4, 3, 2, 1, and on here, do you understand that they would cancel? So like that whole thing and that whole thing, right, would cancel. But I still have a 3 factorial yet. So how do I do 3 factorial? 3 times 2 times 1. Okay, so my goal is to usually look for the bigger one and start expanding the bigger one until you run into a same one on the bottom or on a top or whatever, vice versa. Okay, now give me some numbers here. So just 12 times 11 times 10. So on those ones, I might give you ones that are so big, you might say, oh, well, I could just do this in my calculator. But if I give you something like 100 factorial, guess what? It's too big. Your calculator just can't do it. Think about that number. 100 times 99 times 98 times 97. Think about how big that number is. Your calculator can't handle it, okay?
You doing special ones? How do you
What are you doing? Brackets, 12 times 11 times 10. Brackets, divided by 3 times 2. Okay. Simplify this. So this started at an n plus 3, and then it went n plus 2, which is lowered by 1, and then this keeps lowering by 1. Why can't I just start at that? Right? It'd be like me saying 6 times 5 factorial. Why don't you just start at 6 factorial, right?
But it's a little bit negative when you're not.
Right? An idea like that, you could actually just start at 6 factorial, right? You can't do any of these things with negative numbers. You can't.
N minus 2.
N minus 2 is not a negative number.
Well, no. Definitely not. You don't know what N is.
You don't know what n is, yeah. Okay, ready? Which one of these is the bigger number? Which n plus 1 is a bigger number. So n plus 1, expand. What's the next? If you go down 1, what is it? Just an n. What's 1 lower? N minus 1. And I'm going to stop that. And I'm going to say it just keeps going, going, going. Why did I stop specifically there? because look at my bottom. So this number times this number times da 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 da. Keep going, but all these are also keep going. Does it make sense that this number and beyond would cancel those numbers and beyond? So how do I simplify something like that? N squared plus n. Okay, ready? Start expanding the larger number. So what's larger, an n or an n minus 2? What's a larger number? N. So n, keep going down 1. So what's the lower number? N minus 1, n minus 2, and etc., etc., etc. I stopped there. Because I knew that that would cancel that. Okay, I'm going to teach you applied brain and pre-calc brain, and you can do what you want with that. What does this mean to me? Some number times some number one lower has to make 90. Can you think of a number and a number that's just below it that would times to be 90? 10 times 9.
That's it?
So n equals,
That's nice.
what does n equal? 10.
Oh,
Oh.
what?
So what is those equation numbers?
Okay. Pre-calcy brain? Here's your pre-calcy brain. Ready? What does this do? N squared minus n. How would I solve an equation that looks like this? Equals 0. So I move the 90. If you are already fine with the applied brain, don't even worry about writing this down. Factoring, because that's a quadratic trinomial. n 10 times 9 multiplies to 90. I need to make a negative 1. Therefore, n equals 10 or n equals negative 9, but that's not allowed. Okay. Applied brain, pre-calc brain. That's it.